Thanks, Leon, for that introduction. My name's Max, and I'm really excited to speak to you today about our work in creating an early detection system for the citrus disease, HLB. Currently, more than $1 trillion worth of agricultural production is at risk of a devastating disease outbreak. This risk is increased by our globalized food system, changing ecosystems due to climate change, and the use of food crops that lack the genetic diversity to resist disease outbreaks. There are three key drivers to addressing the challenge of disease in food crops. First, you must have knowledge of the disease, its cause, symptoms, and methods of spread. Second, you must have proven strategies to mitigate the disease. Third, you must have an effective method of detection to permit precise understanding of where the disease is located. When one driver is missing or is inadequate, an effective response to disease may not be possible. In this project, we are innovating to improve our capabilities in crop disease detection. In particular, we address the detection challenge posed by the citrus disease, HLB. HLB is an incurable citrus disease that ultimately kills the affected plant. On top of this, HLB has a long asymptomatic period of well over a year. Therefore, early detection is critical to halting its spread. The combination of these factors has made HLB a profound challenge to citrus agriculture. HLB is a global problem, as illustrated by the yellow and green areas of this map that indicate regions where HLB is present. We have good knowledge of HLB disease, what causes it, how it's spread, and its progression. We also have strategies to mitigate HLB disease. For instance, quickly removing and replacing HLB-positive trees is a strategy that keeps a citrus grove profitable. However, current methods of HLB early detection are inadequate, and thus HLB is currently incredibly hard to manage. Take, for example, the situation in the state of Florida. In 2008, HLB was first identified in the state. By 2014, HLB had become a destructive epidemic, leading to more than a 40% reduction in statewide acreage. Nearly 100% of citrus in Florida have HLB. But the story doesn't end there. HLB is also a threat in California, where 85% of US fresh citrus is produced. In 2014, HLB was first identified. The question is, when will it become an epidemic? The answer is we don't know because we don't have adequate means of detecting the disease at early stages. Leaf-by-leaf PCR tests are the current method of early HLB detection. This requires leaf removal from the tree and a subsequent test days or even weeks later at an off-site location. The disease resides at a handful of leaves out of many thousands at early stages. Thus, the chances of detecting HLB early using PCR tests is very low. We conducted over 50 stakeholder interviews and identified three key requirements for effective early HLB detection. First, the technology must be highly accurate. Second, it must be timely, in that it must be able to detect HLB just weeks after infection. Finally, it must be affordable to growers. To achieve these requirements, we are creating technology that can detect HLB at the scale of whole trees rather than the leaf-by-leaf testing of PCR. Plants produce signature volatile organic compounds, or VOCs, during disease states. In the case of citrus, signature VOCs are produced when a citrus plant is healthy, as well as just weeks into asymptomatic HLB disease. Therefore, VOCs represent a cloud of detectable biomarkers around the plant. We are using VOCs detection as a whole tree diagnostic for HLB. However, currently available gas sensors do not meet all of the requirements for field detection of HLB. For example, mass spec is highly sensitive, but it comes at a prohibitive cost. We've invented a patent-pending sensors technology that meets the requirements of the HLB detection challenge. The invented sensors technology is humidity-initiated gas sensors, or Higgs sensors. Higgs sensors employ the impedance of water vapor self-assembled at sensor surfaces to detect VOCs at low concentrations. Since water is the medium by which Higgs sensors detect VOCs, complex and costly conductive materials are not needed. Also, since Higgs sensors exploit ambient water vapor rather than treat them as an undesirable contaminant, Higgs sensors demonstrate remarkable humidity resilience. We will deploy our sensors technology to California to halt the spread of HLB. Confirmed cases of HLB, shown in red, are located in Southern California, shown in green. However, HLB threatens to spread north to the San Joaquin Valley, shown in blue. The San Joaquin Valley incorporates 80% of California's citrus acreage. We will deploy a statewide detection service to enhance HLB mitigation in Southern California, but also to protect the high production in the San Joaquin Valley. To do this, we will perform detection at Southern California groves proximal to the current HLB perimeter. In addition, we will also select groves in the San Joaquin Valley to provide a rapid alert should HLB appear. Currently, we are prototyping devices. Later this year, we plan to perform a pilot with citrus. We then plan on deploying an HLB detection service next year. Thanks so much for your attention. I look forward to speaking with potential investors and collaborators in the breakout session.